Hi there and welcome to this video. In this video, I'll be discussing with you what is a Huffman coding, or that is also known as optimal algorithm. This is a compression algorithm. What is a compression algorithm? That whenever we are transferring the data from one system to another system, then instead of sending the actual data, we just compress the data and then we transfer the data. Okay. Now, but before shifting on to the Huffman coding, I would like to discuss with you that why we need that Huffman coding, why that is actually needed. Okay. So I have just taken an example. Suppose I have this message. I want to transfer this message. Okay. Now this message is having various number of characters. Like we are having A, B, C, D, E. Because while transferring, we can have any data with us, right? We can have symbols with us. Whatever is present on the keyboard, we can just represent that, right? So for that, I have just taken the example of the characters. Okay. Now, if you can just notice that the some of the characters are occurring more number of times, okay? But in general scenario, now see, these are my characters. I have chosen, okay? Now these many characters are repeating itself, okay? We can have any number of characters, okay? Suppose if I want to transfer a data, transfer a message, hi, how are you? Now in this H is coming 2 times, okay? So there could be a case then when my characters are repeating, or there could be a case when they are not repeating, right? So we are talking in general that if I want to transfer the data, then my data consists of, suppose this is my string, this is my message which I want to transfer, right? Now in general format, you must be knowing that every key on a keyboard has one SCI value associated with it. Why we need that SCI value? SCI stands for American Standard Code for Information Interchange, right? Now why we need that SCI value? Because whenever we are dealing in computers, my computer only understand your binary data, the data in the form of 0 and 1, right? So whenever you are pressing any key from the keyboard, that key is actually getting transferred into its associated ASCII value, and then the work is being performed by your processor, right? So similarly, now each ASCII value consists of 8 bits, okay? So for example, now in this message, I have total 20 number of characters. Okay, if you make a count of these characters, these are 20 number of characters. Now my ASCII value takes 8 bits. Okay, so if I have now small a, the ASCII value of small a is 97. Okay, so I need to translate this 97 into its binary format. If you don't know how to make this conversion, you can also visit my another video that is related to the digital electronics, where I have covered how to convert your binary data into decimal or decimal into binary or another base systems conversion, right? Similarly, small b is having your ASCII value that is 98. Small c is having ASCII value 99. So in every case, we need a conversion of this decimal value into this binary format. Okay. And now if you can just notice that each binary value consists of 8 bits. So that means if I have total 20 number of characters, so I need 20 into 8. That means total 160 bits to transfer the data, right? This was the one form when we don't have any compressive algorithm, or from one system to another system, right? We were sending the data as it is. We need to send the whole data, right? And each character consists of your 8 bits. Okay. Don't get confused with the fact, what if I am sending plus sign over here? No issues, because plus sign is also having one ASCII value associated with it, right? So whenever you are transferring any kind of data, that data is basically getting converted into binary format, from where it could recognize that how much space is actually required in order to make a transfer, right? And then your data is getting transferred. This was the very old technique, right? When we don't have any algorithms with us, right? This is no doubt, in this we don't need any encryption and decryption kind of techniques, but this is very space consuming concept, right? So in order to avoid this, what we can do, we can just deal with fixed size encoding techniques. Okay, now what is fixed size encoding? That instead of sending this 8 bit of data, I can assign some fixed codes to these characters. Okay, how I can assign? Now again, we know that our computer processor only deals with the binary format, that is either 0 or 1, right? So that means I have only two possible values. So I can varies with the combination of 0 and 1. Okay, so first of all, let's just take a variation, that is 2 raised to power 0. Now anything raised to power 0 gives me 1. So that means I have only one single value. I cannot represent 5 characters with one single value. So I won't take this. Okay. Next variation is 2 raised to power 1. Now 2 power 1 can have two values, either 0 or 1. Suppose if I assign 0 to A and 1 to B, what about C, D, E? I don't have anything, right? So I need to move further. Let's take 2 raised to power 2. 2 raised to power 2 is 4. So that means I can move in the variations of my bits. That means 0, 0, 0, 1, 1, 0, 1, 1. So that means if I am assigning A 0, 0, I need to assign B 0, 1, then C 1, 0, then D 1, 1. But there is nothing for E. So I cannot even take this 2 raised to power 2. So let's move on to the 2 raised to power 3. Okay, now 2 raised to power 3 means you can have the combination of 3 bits. Okay, so these are the combination of 3 bits. All the 3 bits could be 0, last bit could be 1, middle bit could be 1. Okay, so these are the different combinations. If you don't aware about these things, you can just view my another videos that is related to the digital electronics, right? Now out of these 8 bits, this is my choice. I can assign any combination to A, any combination to B, any combination to C, D and E. That is entirely my choice because I have only 5 characters but I have 8 combinations. So I can assign them accordingly, right? Now what will happen, suppose if I am going to assign the code, I am assigning the very first code, that is 000 to A, then 001 to B, then 010 to C, and then D, and then E, right? But the point comes whenever you are going to make this kind of transfer, what will happen? Earlier I need to transfer 8 bits for each character, but here the number of bits have been reduced. Instead of sending 8 bits, now I need to send only 3 bits for each character. Definitely the space required would be less. There is one problem. Okay, what is that problem? Now I am saying you have total 8 combination. Now it's entirely my choice that maybe I can assign 101 to A. That is my choice, right? Because I do have these options. Out of these options, I can assign any code to A, any code to B, to C, to D, to E, right? Now if I am assigning any code, how the receiver will come to know that which code I have assigned to A, which code I have assigned to B? Receiver cannot come to know automatically about this thing, right? So that means while making a transfer of this message, along with this message I also need to send this coding table so that receiver could decode the encrypted message. This would be an encrypted message whenever I am going to make a transfer. Instead of sending B, I'll send 001. Okay, now on the receiving end, how the receiver will come to know that 001 is corresponding code for B? How your receiver will come to know? Receiver cannot come to know unless and until with the message, I am also sending these codings. Okay, so that means in this coding technique, what I need to send, first of all, I need to send this coding table. Now this coding table consists of two parts, right? One is character, one is code associated with each character, right? Now how many characters are there? That is total number of characters are 5. That is A, B, C, D, E, right? And these characters need to be transferred with their ASCII value. So that means 5 into 8, right? Next, I need to send this codings. Okay, this codes. Now each code consists of 3 bits. And how many codes I need to assign? That is 5 codes because I have total 5 number of characters, right? So 3 into 5, that makes it 15, right? And how many number of bits are required for this message? Each character is taking 3 bits and I have total 20 number of characters. So 20 into 3, that will give me 60. On adding all these 3 numbers, I'll get 115 bits. Okay, earlier I was using 160 bits in order to make a transfer of 20 characters. Now with the fixed size coding technique, I am using 115 bits in order to make a transfer of the same message, right? But this is a fixed size coding technique in which each character is assigned a fixed format, fixed code, right? But we do have another technique in which size could be reduced more. Okay, size could be reduced more. How and what is that? Compressive, that is known as compression algorithm. That compression algorithm is known as Huffman coding. Let's just understand that with the help of definition first, right? It is used for the lossless compression of data. Now what is this lossless term? See, when you are sending a data, hi, how are you, I cannot afford that receiver will receive only how are you, receive hi, how are you. The actual message which I am sending, receiver should receive the same message, right? So that is known as lossless compression, that while compressing the data, we are not reducing or we are not cutting any character, right? It uses the variable length encoding. Now we do have two types of encoding technique. One is known as fixed length, which we have already discussed. Another one is your variable length, right? Now the code length of character depends on how frequently it occurs in the given text. Okay, now in Huffman coding, we need not to remember, which code has been assigned to A, which has been assigned to B. No, we need not to remember all that kind of stuff, right? How we are going to calculate? We are going to calculate the code on the basis of the frequency of each character, right? Then there are mainly two parts, major parts of Huffman coding. What are those? The first one is build the Huffman tree, okay, on the basis of the input characters. Second one is traverse the tree and assign the codes. I have taken the same example like we did discuss in fixed size encoding and the before compression techniques, okay, before this fixed size or variable size encoding, the techniques that we were using, I have taken the same example, okay. But in case of Huffman coding, what we are going to do, we are going to make a table in which we are going to, first of all, we are going to write down the characters which are appearing in our message. Secondly, we are going to write down the frequency of each character. Okay, now in this message, A is coming 3 times. If you can make a count, A, 1, 2, 3. Similarly, B is coming 5 times. 1, 2, 3, then 4 and 5. Similarly for C, for D, for E. Okay, now how to make, okay, so this is your first table, that is with each character we are going to write down the frequency of that character, how many times it is existing in my message, okay. Now, as you have read in the definition of Huffman coding, that the very first step is build a Huffman tree. How to build that tree? First of all, choose the minimum frequency characters from your table. Okay, now when I make a choice, this one is the minimum value in my table and the second minimum value is 3. Obviously, if you want to build a binary tree, you need two nodes for that, right? Left node and right node, right? So I have chosen these two values, okay, which are the minimum one in my table, right? 2 and 3. Now the question comes, which should appear as the left child and which should appear as the right child? So the value which is less is going to be my left child and the value which is greater is going to be my right child, okay? So the very first subtree I am going to create is, first of all, I have written 2 on the left and 3 on the right. Now I am going to add these two values and the sum is going to be 5. Root would be the sum of two children. Okay, so 2 plus 3 gives me 5. 2 is representing E and 3 is representing A. Okay, now you need to make a comparison between this root, that is 5, and your frequency table. Now, if you can just have a look at the frequency table, now I have chosen 3 and 2. I am not going to choose them again, right? So now make a comparison with 5. If there any value which is less than 5, yes, there is a value which is less than 5, which is known as 4. Now I am going to choose that 4. But as I have already discussed that the value which is lesser is going to be the left child. So I am going to put this D value on the left of the subtree. Okay. So I am going to make a root by adding these two values, that is 5 and 4. Okay. So when I make addition of these two, it becomes 9. Okay, now when I make a comparison in my table, I have seen that 3 I have taken, 2 I have taken, 4 I have taken. So I am left only with the two values, that is 6 and 5. Okay, now 6 and 5 are less than 9. Okay, so I cannot make a choice between 6 and 5 because they both are less than 9. Okay, so what I'll do, I'll make a subtree of these two nodes. Okay, I'll make a subtree which is having these two nodes. Okay, now when you add these two nodes, what would be the result? That would be greater than 9. So I am going to take these as the right part of my tree. Okay, so this would be 5, this would be 6. If you can just have a look that in this subtree, 5 is the child and 6 is the right child. So when I make addition of these values, it will give me 11. And when I add these 11 and 9, it is going to give me 20. Now in my message, I have total 20 number of characters. So my ultimate root should be 20. My ultimate root is 20. Right? Now the next step was, it says, the definition says that there are two major steps. One, how to build a Huffman tree. Second, how to traverse each node. Now I have made the first step, that is I have built the Huffman tree. Now the second step is how to traverse. Suppose if I want to reach to node A, I don't have any way. Okay, so how you are going to make that path, how you are going to make that way? Assign all the left node as the value 0, or rather I would say assign all the left paths as 0. If you can see, this is an edge between these two nodes, so I'll assign 0. Now I have not assigned anything to the right edge. Okay, I have not assigned anything to the right nodes. Now to all the left node assign 0 and to all the right node assign 1. This is the rule. Because ultimately what we are saying that my processor is understanding only 0 and 1. So I need to assign values out of 0 and 1. Okay, so what I have done, assign 0 to the left and assign 1 to the right. Okay, now build up codes. How you are going to build up those codes? Now let's have a look carefully. If I want to reach to A, obviously if I'm talking about tree, I cannot reach to A directly. I need to traverse it through the root. Okay, so this is my root. So first of all, I need to traverse this, that is 0. Then I'll traverse this, that is 1, and then this A, that is 1. So the code would be 0, 1, 1. If I want to traverse this B, I'll start from root again, that is 1, and there is 0. So my code would be 1, 0. C, first of all, I'll traverse this 1 and then 1. So code would be 1, 1. D, now what is D? First of all 0 and then 0. That is 0, 0. And what about E? That is 0, then 1, then 0. So the code would be 0, 1 and 0. Okay, so here if you can just have a look, in fixed size encoding technique, what was the rule? That each character was having 3 bits. But here we have variable size encoding. That is why we call Huffman as a variable size encoding. Because each character, some of the characters are having 3 bits, some of the characters are having 2 bits. Maybe if I change the message length or if I introduce some of the new characters, maybe any of the character would also hold 1 bit or 5 bit or 10 bits. We don't know about that, right? So this is how we are going to assign the codes in Huffman coding. Okay, we need not to remember anything, right? So now let's just calculate how this is working as a greedy algorithm. That means let's just check that how we have reduced the space. Okay, now let's just make a calculation how much total space is required. Okay, so first of all, A required 3 bits. Okay, and how many time A is coming? That is 3 times. So 3 into 3, total 9 bits are required. B required 2 bits, and how many time B is coming? That is 5 times. So 5 into 2 gives me 10 bits. Okay, C codes is of 2 bits, and how many time it is coming? That is 6 times. So 2 into 6 gives me 12. So D bits is 2 bits, and how many times it is coming? 4 times. So 2 into 4 will give me 8. So E is having 3 bits, and how many time E is coming? That is 2 times. So 2 into 3 will give me 6. Okay. So total how many bits are required for this? That is 45 bits. If I make addition of 9 plus 12 plus 10 plus 8 plus 6, that will give me 45 bits. This is the one thing. Now in this also, if I am sending this coding, variable size coding, that at the decoder end, at the receiver end, I need to send the codes, right? But here, how many number of character size is again going to be the same. How many number of characters are there? That is 5, and each character requires 8 bits. So 5 into 8 will give me 40. Okay. Along with that, I need to send this table, as we have discussed in the fixed size encoding, that what encoding technique we are using, our receiver is not aware about that. So we need to send us this code snippet, this code table also along with the message, so that at the receiver end, receiver can decode all the code so that receiver can get this actual message. Okay, so along with these characters, I need to send these codes. Okay, now for these codes, how many bits are required? 3 plus 2 plus 2 plus 2 plus 3. Okay, so it will give me, okay, so total how much space would be required? That is 45 plus 40 plus this 12. Okay, so total it would be 45 plus 40 plus 12, which is 97 bits. Okay, in the earlier technique, when we were using no coding formats, we need 160 bits in order to make a transfer of this 20 character message. When we use fixed length encoding, we use 115 bits in order to make a transfer of the same message. Now when I'm using Huffman code, I need only 97 bits in order to make a transfer. Okay, so now you can see how this is the most appropriate approach in order to send a message from one end to another end. Okay, see, in fixed size encoding, my size has been reduced, but in Huffman, that is reduced more. Okay, so that is why it is also known as greedy algorithm. Okay, I hope you have understood how this Huffman codings are working and how to make that Huffman tree. If still you have any doubt, you are free to post your comment in the comment section, and definitely I'll revert back to you. If you have any problem related to the number system, then you can also watch my another videos which are on how you can convert a decimal number into binary or a binary number into decimal. Okay, I hope you have enjoyed the video, and if you like my video, please don't forget to subscribe to my channel. Thank you. Bye bye.